Welcome everyone. We are doing section 11.5, which is about what's called partial fraction decomposition. So we need to do a few preliminary things first, and then we'll look at some examples. First of all, our goal. Our goal is to take proper fractions and rewrite them in a new form, and this is a useful thing to be able to do for calculus. You need to know what a proper fraction is. Now, hopefully you know what a proper fraction is with normal ordinary fractions. That's just a fraction where the numerator is less than the denominator. Well, it's a similar idea when you're dealing with variables. Now, a fraction with variables is called a rational expression, and these are proper if the degree of the numerator is less than the degree of the denominator. So similar idea, you want the top to be less than the bottom, but for expressions with variables, it's proper if the degree of the top is less than the degree of the bottom. So for instance, this is a proper fraction because the degree of the top is less than the degree of the bottom. This is not a proper fraction because the degree on the top is larger. This is not a proper fraction because the degrees are equal. And this is not a proper fraction because if you actually multiply out this numerator, it's going to have an x to the sixth term. The denominator has an x to the sixth term, and so again, they're equal. So this is the only one where we have a proper fraction. So, continuing on, in order to completely understand this concept, you need to know what a linear polynomial is. A linear polynomial is a polynomial that looks like this, and a can be anything except it can't be 0. So, for example, 2x plus 3 is a linear polynomial. And why is that called a linear polynomial? Throw a y in front of there, and you know that when you graph it, you're going to get a line. That's why it's called a linear polynomial. A quadratic polynomial, as I imagine you know, is a polynomial basically where the highest power is 2. You need to know what an irreducible quadratic polynomial is. An irreducible quadratic polynomial is a quadratic polynomial that cannot be factored using real numbers. Now, what do I mean by that? Well, take a look at this. This is a quadratic polynomial that can be factored. In fact, this one factors as x plus 2 times x minus 6. This one cannot be factored using real numbers. Now you can factor it, and let's see, I've just written down somewhere here. Yes, this factors as x minus 2 plus 3i and x minus 2 minus 3i. Notice in the factoring I had to use I. If you have to use I in the factoring, then we say that it is irreducible. So, take a moment and just read this fact. Every polynomial, as long as it has real coefficients, can always be factored into a product of linear or irreducible quadratic factors. For instance, take a look at this polynomial here. It turns out that polynomial factors like so. And notice all of its factors are either linear or they are irreducible quadratics. These quadratics are both irreducible. You can always do that for any polynomial with real coefficients. Okay. Take a moment again and read this fact. So that fact should be fairly obvious, at least when I tell you what this is really saying. This is saying the following. Suppose that two people wrote down the same polynomial. One person wrote this down, and the other person wrote this down, and these polynomials are supposed to be exactly the same. Well, if they're exactly the same, and if the coefficient of x squared is 5, then a here must be 5, because it's the coefficient of x squared. So we can determine that a is 5. Similarly, if these polynomials are equal to each other, then their coefficients must be equal. So that means 7, the coefficient of x, must be equal to negative 3k, the coefficient of x on that side, and divide both sides by negative 3, and that tells you that k must be equal to negative 7/3. So anytime two polynomials are equal to each other, their coefficients must be equal. Their corresponding coefficients must be equal, which again, I hope is a relatively obvious fact. Okay, so what is partial fraction decomposition, which is what this whole section's about? Partial fraction decomposition is basically the opposite of adding or subtracting fractions. For instance, if I ask you to add these two fractions, I'm sure you know how to do it with common denominators, and you would end up with this. Our goal here is to take the answer and split it back up into two fractions. Now, not just any two fractions, but two particular fractions, and you'll see how this works in a moment. These are the steps for how this is done, and these are certain rules that have to be followed. I'm not going to go through and read all of these, and I'm not even asking you to read all of these right now, but I will probably scroll back and refer to these now and then as we're doing examples. Okay, we're now ready for our first example. So we're going to find the partial fraction decomposition of this. To do that, we write down the thing that we're finding the partial fraction decomposition of, and then we write down the fractions we're going to turn this into. So you take what you're starting with, and if it's the denominator is factored, you copy down the factors. So x plus 1 and x plus 2 squared. In your numerator, you put capital letters, so capital A and capital B. But because we have a power out here, there's more that we have to do. We make a third fraction in this case. We put a c on top of it, and we put x plus 2 without the power. Now, before we continue with this particular example, let me just give you an alternate example. Suppose that we had a 4 here. If we had a 4, we would put the following. We would have an x plus 1 fraction, and then we would have the x plus 2 to the 4th, followed by an x plus 2 to the 3rd, followed by an x plus 2 squared, and followed by an x plus 2 without a power on it. And these would be A, B, C, D, and E. Let me scroll backwards for a moment and show you where this is coming from. This is coming from this rule here. If one of the factors is raised to a power, then you need to include all lower powers of that also. So, as I just showed you here, if you had a 4, which we don't, but if you did, you'd have 4 and all the powers below it also. But again, we don't have 4 in this case, we have a 2, so that's why we included the power of 2 and the one and only power below that, which is just x plus 2 to the 1. So let's get rid of this, because that's not really part of our problem here. And let's continue on as soon as I get this erasing done. Almost done with the erasing. Okay. The next thing we do is we get rid of all of our denominators, and we do that by multiplying both sides by whatever the denominator on the left is. So everything's going to be multiplied by x plus 1 times x plus 2 squared. On the left side, when we do that, everything just cancels, and we end up with 2x. On the right side, the x plus 1's cancel, and we end up with a times x plus 2 squared. Here, the x plus 2 squareds cancel, and we end up with b times x plus 1. And the last fraction, one of the x plus 2's cancel with the 1 on the bottom, leaving us with x plus 1 times x plus 2 times the c, of course. Okay, we are going to do this using the plug-in method. There's also something called the coefficient method, which we'll look at in other examples. So the plug-in method works this way. Pick any number in the world you want and plug that number in. Plug that number in everywhere you see x. I'm going to plug in the number -2 for x, and I'll explain why eventually. So plugging -2 in for x is going to give us this. Then on the left side we have -4. On the right side we have a times 0 plus b times -1 plus c times -1 times 0. And a times 0 is 0, so that disappears. C times -1 times 0 is 0, that disappears. And b times -1 is b. And if -4 equals -b, then b equals +4, and there is one of our answers. Now, why did I choose -2? The reason I chose -2 is because I wanted this expression to turn into 0. That would make the a disappear. In other words, I chose the number that made this equal to 0. Luckily, that also made this expression equal to 0, and the c disappeared, and I was left with only the variable b. And that allows me to get the answer for b. So now we still need to find a, and we still need to find c. The way we do that is we go back to this line right here, and we plug in another number. But before we do that, let me copy this down. 2x equals a times x plus 2 squared plus, and this is very important, when you go back to that line, if you know the value of any variable, be sure you plug it in. So that's a 4 instead of b, and then we have x plus 1 plus c times x plus 1 times x plus 2. So what am I going to plug in now? I'm going to plug in -1 for x. When I do that, that's going to make this term 0, which will make the c disappear, and the only variable remaining will be a, and then I can get a from that. So I'm going to get a times -1 plus 2 squared plus 4, guess I'll distribute this, 4x plus 4, plus c times -1 plus 1 times -1 plus 2. This part becomes 0, so the whole thing disappears. And, oops, I forgot to plug in the -1 here. We're going to have a -1 there, which means we're going to have 4 times 0, so that will disappear. And we'll be left with negative 2 on the left. And over here, you will have positive 1 squared, which is 1. So you'll have a times 1, and that just gives you a equals negative 2. So now we know what a is, and we know what b is. We need to figure out what c is. So how do we figure out what c is? Well, let's go back to our green line up here and copy that down again. When we copy down that green line, we are going to have 2, oops, you know what? Let's do it in green. 2x equals a times x plus 2 squared, and we now know that a is negative 2, so negative 2 times x plus 2 squared, plus b, which we know is 4, and that was b times x plus 1, plus c, which we don't know yet, times x plus 1 times x plus 2. Let me just double check and see if that's right. I believe that is. Looks right to me. Yes. Okay. So what are we going to plug in? Well, we can't plug in negative 2 because that'll make c disappear. We don't want c to disappear. We're trying to figure out what c is. We can't plug in negative 1 for the same reason. So what do we plug in? You might want to pause the video and give that some thought before you get the answer from me. So pause the video if you're interested in thinking about that. Okay, so what do we plug in? You can plug in anything you want. As long as you don't plug in negative 1 and you don't plug in negative 2, you're going to be fine here. Anything else will give you the answer. So I'm going to plug in 0. I don't think you have to plug in 0. Anything else will work, but 0 is a nice, easy number to deal with, so I'm going to plug in 0. So I'm going to get 2 times 0 equals negative 2 times 0 plus 2 squared plus 4 times 0 plus 1 plus c times 0 plus 1 times 0 plus 2. That's going to give me 0 equals negative 2 times, that's 2 squared, so 4, plus 4 times 1 plus c times 1 times 2. And that gives me 0 equals negative 8 plus 4 plus 2c. And notice, everything has disappeared. The only variable I have left is c, which is what I'm trying to find. So I get 0 equals negative 4 plus 2c. So 2c equals positive 4, which gives me c equals 4 over 2. In other words, 2. So we now know that c equals 2. So what do we have? We have 2 for c. We have negative 2 for a. And we have, and we have 4 for b. So now we go back to our very original line. Let me get back to that original line. Excuse me, that line is right here. I'm going to copy this line down. Do a copy and paste. One moment while I do this. Ooh, we don't have a lot of room here. Let me push some things out of the way. Again, one moment while I do it. Okay, there's that line. I also need to be sure I get the values of a, b, and c. So C turned out to be 2. Let's see what A and B turned out to be. A is -2, B is 4. A is -2, B is 4. So our original expression was this: 2 over x plus 1 times x plus 2 squared is equal to A over x plus 1 plus B over x plus 2 squared plus C over x plus 2. And now we figured out what A, B, and C are, so now we just put those in place. So this, since A is -2, is -2 over x plus 1, plus B is 4, so plus 4 over x plus 2 squared, plus C is +2, plus 2 over x plus 2, and we are done. This is the partial fraction decomposition of this expression right here. So that is example 1. That's the end of this particular recording, and the next examples will come up in the next recording.